These notes are a continuation of the unit circle. So at this point, we have now split up our unit circle instead of into 4 pieces, as we did in our previous video. We've now split it up into 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8. And so I know that I have basically, again, my degrees here are 0, 360 degrees. If I split up 360 by 8, that gets me 45 degrees, 90 degrees, 135 degrees, 180 degrees, 225, 270, and 315 degrees. We also know that the other thing we can do with the unit circle is that we can talk about the circle being in radians. So since I've cut my circle up into eighths, I would take my full circle of 2 pi and cut them up into 1/8, 2/8, 3/8. Rewrite that just a little bit so it's a little clearer. 4/8, 5/8, 6/8, 7/8, and 8/8, which I can reduce so that this is actually pi over 4. We've already seen this one, pi over 2, 3 pi over 4. We've already seen this one, it's pi. 5 pi over 4. We've already seen this one, it's 3 pi over 2. 7 pi over 4. And then, of course, we've already seen this one, it is 2 pi. So now we have degrees and radians. Just like in our first circle, in our first unit circle that we talked about, we also want to find these points. So we found these points already. This is 1, 0, 0, 1, negative 1, 0, 0, negative 1. But we also need to find these 4 points here. And in order to do that, the easiest way is to set up a right triangle and use some trigonometry. So I'm going to set up this triangle. And because this is 45 degrees, I know that this must also be 45 degrees. And so now I have a right triangle that is a 45, 45, 90 triangle. And we know from last year that the ratio of a 45, 45, 90 triangle is x, x, x root 2. However, in this case, in our triangle, we know that the hypotenuse is 1, which means we know that x root 2 equals 1, which means x equals 1 over root 2. But mathematically, a sort of a nicety we have is we don't leave them in this form. We do something called rationalization, and that's when I multiply the top and the bottom so that the bottom no longer is a square root. So I end up with the square root of 2 over the square root of 4, but the whole purpose of this is the square root of 4 is 2. So I now know that both of these lengths are the square root of 2 over the square root of 2, which means this point right here is the square root of 2 over 2, square root of 2 over 2. This triangle is exactly the same 45, 45, 90 triangle. The only catch is that when I've gone this length, it's actually a negative square root of 2 over 2 length. This triangle down here, exactly the same triangle, except now I've gone negative and negative. So it's going to be negative square root of 2, negative square root of 2 over 2. And then this last triangle, again, still 45, 45, 90. And so, however, I went positive and then negative. So positive root 2 over 2 and negative square root of 2 over 2. And so I now have my unit circle filled out up to 45, 45, 90 triangles. Now we have one more triangle, but we look at it from two different perspectives that we talk about when we're talking about special right triangles. Our next special right triangles are going to be our 30, 60, 90. So the first thing we're going to want to do here is label 30. I'm going to stop labeling the axes since we've done that twice now, but we know this is 30. We know this is up 30 from 180, so that's 150. We know this is down 30 from 180, so that's 210. And we know this is down 30 from 360, so that's 330 degrees. We also then have to figure out our radians. And in some ways, the radians is actually easier to figure out once I have 30s and 60 degree triangles on my grid. In this case, we'll just simply talk about the fact that if I had, I'm going to lightly draw in here. Lightly draw in here the 60s, only because then I can see that I've broken the triangle up in the unit circle up into 1, 2, 3, 4, 5, 6, 12 spots. So that this is 2 pi times 1/12, 3 pi times 1/12, 4 pi times 2 pi times 2/12, 2 pi times 3/12. Wait a minute. 1, 2, 3, 4, 5, 6. Yes, I'm sorry. I lost track there for a second. It does. Okay. So then we have 2 pi times 4/12, 2 pi times 5/12, 2 pi times 6/12, 2 pi times 7/12, 8/12, 9/12, 13/12, 7, 8, 9, 10, 11, and then again 12. So then these can be reduced to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So those are our radian measures. And now, just like in our 45, 45, 90 triangle, we have to actually deal with the fact that we need to find these points. So for these points, we have a 30, 60, 90 triangle. So let's look at that up here. 30, 60. We know from previous years that 30, 60, 90 triangles have the pattern of x, x root 3, and 2x. Those are the ratios. However, we also know that in our triangle, we have that the 90-degree angle across from the 90-degree angle is a measure of 1. So we have that these are equal, which means x equals 1/2. So I have 1/2, and I have 1/2 times root 3, which we write as root 3 over 2. So now across from the 30-degree angle, I have 1/2. Across from the 60, I have root 3 over 2. So now I'm actually looking at that length each and every time in these 4 triangles. The length along the x-axis in all of these cases is root 3 over 2. And the length along the y-axis is 1/2. So when I fill in the points, I then say, well, this point is root 3 over 2, 1/2. For this one, when I do my root 3 over 2, I actually went in the negative direction, so it's negative root 3 over 2, 1/2. Same thing, I went to negative and then negative, so negative root 3 over 2 and negative 1/2. And same thing here, positive, but then negative. So negative, positive root 3 over 2, negative 1/2. So this fills in my 30-degree rotations in my right triangle, in my unit circle. The last one we're going to do is our 60-degree rotations in our right triangle, our 60-30, we could call them. So for that, we've actually kind of already counted. We went through and we said that we had 1/12 times 2 pi. This is 2/12 times 2 pi, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9, 10, and then of course the 11 and the 12. So now we can find that the radians here are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And we can fill in the angles. This is a 60-degree angle, so this is 60 degrees. 60 up from 180 is 120. 60 down from 180 is 240. And 60 down from 360 is 300 degrees. Now we've actually already done the work for the 30, 60, 90 triangle on our previous page. We know that our ratios are this. So we know that our ratios are 30, 60, 90, where the 90 is 1, which makes the 30 1/2, and the 60 2. So let's look at just what changes here though, because in this case my 60 is across from my height of my triangle. So this becomes root 3 over 2, and this becomes 1/2, which means this point is 1/2 square root of 3 over 2. So you'll see that actually what ends up changing is that my x and my y switch places, because that's what actually happened to the legs of my triangle. My legs switched places. In this triangle, the longer leg was an x value, and the shorter leg was a y value, and now we've switched them. And so then I follow the same pattern. In quadrant 2, I've gone left 1/2, so that's negative, but up root 3 over 2, so that's positive. In the third quadrant, they're both negative. I've gone negative, negative. In the fourth quadrant, I've gone positive, negative. Now, the nice thing about this is that right now we've sort of built this up piece by piece. But if we wanted to put it all together on one page, it would actually turn out to look like this. And I've done them in different colors so that we can very clearly see. My purples are my 90-degree rotations. My orange are my 45s. My green and blues are the ones that are related. They're all the 30-60 rotations. We can see them there. We have all of the angle measures written. We also have all of the radians written, and we have all of the points identified using what we know about our right triangles.